Hello! In this video we're going to go over how to look up a postcode and obtain its geographical location and then append it to a Folium map. So this program was made for a school's open day. So if I'll show you what the program does first, and then we will and then I'll explain the code. So here we go, RBAI Open Day Map Application, enter postcode. So I'll enter a postcode here. So there's a postcode. I'll click generate, and now we can see that we've created a Folium map. And if you don't know what Folium is, it's essentially a Python library that allows for the creation of HTML maps, and then you can then add your own data in your Python script. But anyway, we'll continue. So what we have here is so we have this map. Okay, it's the map of the entire world. I can zoom out here, and it's the entire world. But if we scroll down, we can see we have two waypoints. We have two waypoints here. And we have in it the location of the school, which is here, and then and that's in the city center, and then we also have the location of this this location here, which is the location of the it's the location of the place where we inputted our postcode for. So this is where BT27HP is. So this is the user input, so that's why it's called that there. And we also have a red line in between them, because the idea of this program was to show you the distance as the bird flies from the school to the place where you inputted it, so people could come up and we could figure out how far they went to travel. So that's what the application does. So we'll go through it step by step now. So we'll just minimize this. Oh, and it also generates additional info regarding the postcode. So for example, their parliamentary constituency is tied to their postcode, and their electoral area is also tied to it. So that's why we have this additional info at the bottom, just to show how much data is associated with your postcode, and that's just the tip of the iceberg when it comes to this. So anyway, we'll close out of that and we'll explain the code. So we have a lot of libraries here. Now we have tkinter because we want to make a GUI. We have mavs because we need to do a bit of mathematics in order to obtain the distance between the 2 points, because Folium does not do that for you. So we have to do that ourselves. We have OS to automatically open the generated HTML files. We have web browser to do that as well, and then we have the images for the images, and random, we need that as well. And then we have the GeoPy geocoders here as well, just to allow us to interact with Folium more. Now this is quite important here, the URL lib request and the JSON library. So I'll explain a bit more when we get to that, why we need both these libraries. So let's start. So that first point, so we'll start with the constants. So that first point was the school's location, and of course that won't change. So that's why we have these two constants here, and that has the precise latitude and longitude of the school. And then if we go down to where the main method starts, well, not the main method, but where we press the button. So whenever we click the generate button, we're going to call get lat long with the inputted postcode. So and again, if stuff like inputted postcode.get is confusing you, Do look back on some other videos, because this is just going overview. It's quite a high level program, so we're just, gotta assume knowledge here. Otherwise the video would be quite long. But anyway, we'll continue. So get lat long. So let's go over here. So get lat long is called as soon as we press the button and we get passed in the postcode. So obtain the dictionary of data associated with the postcode. So this is where the URL lib comes in. So we're going to make a URL request to the website postcodes.io, api.postcodes.io, and this is going to be the URL. Okay, so this is quite confusing. What is this? Well, this is a format. So this is the request. This is the method we're calling. So it's from the URLB library. We're calling this request library of that module, and this is the method we're calling URL open. So just demonstrate this. Okay, so this is a format string. So up to here is a format string. So so this is the URL, and these open brackets here is where the postcode goes. So let's take this and we'll replicate what the program did here. So we'll go over here, go to a new tab, and we'll say http API postcodes.io, postcodes, and then the semicolon. So we don't actually type the squiggly brackets. Instead, that's the format string. So the format string will put in the postcode that was input. So BT2 7HP. So whenever we run this, we get back a JSON output. So this is JSON, okay? And as you can see, it's a JSON dictionary. JSON dictionary of all the data that's associated with that. So, i.e. the country, which is Northern Ireland, and then here you can see all the data that was associated with it. So things like the what do you call it? The parliamentary area, etc. You can see parliamentary constituency, etc. Things like that. Here. So again, that was only three bits of data I showed you, and you can see there's a whole load more. So how are we doing this? How is this working? Well, we're making a URL request. That's what that was that we just did there, to api.postcodes.io. So what is this? Well, Postcodes.io is an open source project maintained by Ideal Postcodes. It is a free resource allowing developers to search, reverse geocode, and extract UK postcodes and associated data. So that's what it does. So we've done that, and the main reason why, although the displaying of the data was quite nice, of the parliamentary constituency, etc., what we really wanted to get was the longitude and latitude values here, because that's how we're going to put the point on the map. Otherwise, we've no idea how to get it. So, otherwise we wouldn't know where to put the marker. So that's why we primarily do this, but then of course it's nice to show off what other data is associated with it. So, again, this is the documentation. If you want to explore more, I highly recommend reading it. It's quite well maintained and quite clear documentation. But this is essentially what we did. Postcode lookup, and then instead of this semicolon postcode, we just supplement our own postcode there. And that's a JSON GET request there. Okay, so that's how that all works. So we're using postcodes.io to get the latitude and longitude of the location inputted. Okay. And if you're watching this from abroad, please bear in mind this is UK postcodes only. So it won't work for Ireland, won't work for India, won't work for America, etc. But there'll probably be other APIs for whatever. If your country has a postal service, there'll probably be an API for that. So do a bit of Googling and find it out for yourselves. But for those living in Scotland, Wales, England, and Northern Ireland, this is what you'd use. Anyway, so we'll minimize that. Okay, so data equals JSON.loadRes. So what are we doing here? Okay, so so the program has seen this. Okay, we've obtained this through the URL request. The URL lib, URL open library gets us in this res, which is the raw JSON. Okay, so how's Python gonna solve this? Because literally we just got this big string of the dictionary, but Python doesn't know that. The program doesn't know that. So what we do is we call the JSON.loads library, which will convert that JSON dictionary into a Python dictionary. So that's what this does here, this line. So that's why we need the JSON library for that. And then we make a map. Okay, so make map. What are we doing here with make map? Well, this is a separate function which we've defined. So I'll leave that, and again we do that. There's a separate function there. So we'll go on to those in a bit. Just want to make sure that since this is a request and it's going out on the internet, it could fail. So say the postcodes.io website is down for maintenance, then we won't be able to get that. So that's why it's very important to encapsulate a URL request with a try accepts. And this is a very generic one. Just says accept error as E, print the E, and then show an error message to the user. But anyway, we'll make this map function. So make map. So let's find where make map is defined. Make map's here. Okay, so this is where the folium comes in. So M is our map object. So we're saying M equals folium.map, and we're passing into the constructor for map the location of inst, the initial zoom value, so we're not really zoomed out and showing the entire world if all we're concerned with is the British kingdom, the United Kingdom. And then this tiles is sort of, I believe that's just the style. So I think you can have satellite images, you can have other things. So if you want, you can play around with that. But that's the style that creates this sort of which shows you the roads, but isn't pure satellite view, if you know what I mean. Anyway, we'll continue. Tooltip equals click me. Okay, so that's just a string, and then it says folium.marker. So the marker object is this blue object here. That's the marker object. What we're saying is we're setting one of these to make to the inst latitude and longitude. That's this one here, and then then it's going to say pop up, which is the value. So whenever we click this, so that's what the pop up will be like. What will be displayed in that little bubble there, and then the tooltip just says click me. So, and then we do that, and then we add to the map object. The reason why we have this is, of course, if you had multiple map objects, how would Python know which map object to put it to? So that's why we do add to M. And then we also have the user input one here. So what's this data? Where are we? So what's this data value here? Data. So as previously mentioned, if we go back up to the to this here, we're passing data is our Python dictionary of the URL request, of the JSON URL request. So here it is here. So it is actually a 2D dictionary, kind of like a 2D array, but instead of 2 indexes, it's 2 keys, I believe. So that's what we have here. So don't be alarmed. It's just essentially a 2D array, well, 2D dictionary, but yeah. So you get it. So that's how we access it, the data, through that, and then we add it to the map. So list of tuples containing lat and longs to create a line. Okay, so so this is how we create that red line between the 2 points. So we have our list of tuples. So this is a tuple, the round brackets here. So we need, since there's only 2 points, we only need 2 tuples. That would be the latitude and longitude for inst, and the latitude and longitude for the user's input. Okay. So remember I mentioned that that Folium will not calculate the distance between the 2 points. As you can see here, we do have that. If we mouse over it, we have 0.74 kilometers as the crow flies. So we're going to need to calculate that distance. So this is where we call our Haversine formula. Okay, so we're passing in the latitude and longitude of the user's input, and we're also passing in the longitude and latitude of inst of the point that we already have. So let's go to the Haversine formula now. Let's go. Let's see. Where is it? Here it is. So calculate the great circle distance between 2 points on the Earth. Sorry, calculate the distance. I don't know why it says great circle there. It was a little while, but anyway, calculate the distance between 2 points on the Earth specified in decimal degrees. So this is a little complicated, a little complex. So I'd say just Google it if you're a bit more interested into it. It's a bit of trigonometry here, a bit of trig, a bit of mavs here. But again, just Google it. I mean, to be honest, this formula is quite well known, so just there's probably already a script for it, or you can just use this one. Anyway, I'll not dive too deep into this. Okay, so radius of Earth, so we're going to multiply that, and then we're going to round it, and we're going to return the distance. So that's essentially what it is. I'm sorry I can't give a more high-level explanation, but I don't want the video to be really long, so let's not bother with that. Let's just say that you've calculated the distance using this. Okay, so we've got our distance in kilometers. Yes. So we've done it. So we've done that. So make map. So we're back to make map. So that is up. Sorry, where is it? Hold on, I've lost it. There we go. So that's our make map. So okay, so we've got the distance that's been returned, and then we do folium.polyline. So the polyline object is this red line here. Okay, and we're passing in points. That you need the points. That's the list of tuples for the 2 destinations, the two endpoints of the line. Then you can make the color red. You can make it blue. I think this accepts. I think it'll accept any color, kind of like Tkinter, where it has a set of predefined colors, and then you could make your own using hex or RGB values. But I just went for the simple red. Then you can change the width of the line, the opacity of it, etc. And then the tooltip, that's important. So the tooltip is what you get when you hover over it, so 0.74. And again, if you're having difficulty, I remember when I was developing this, if you're having difficulty mousing over the line, just increase the width of the line, and that'll help. And here it's as simple as converting the distance into a string and appending kilometers to it, and we add that to the map. So again, this is important. .add2 is adding to that map object there. m.save the HTML page, and then what we do is we open it using our web browser, and OS is used to obtain the path of inst opendaymap.html, which is here, so it'll be in the directory there. The reason why we use real path is so it's dynamic, so if you hit it in another folder or whatever, it would still be able to find it. So that's why we do that. Okay, so now you've opened the map. So that's the end of make map. So we go back to our getLat long, and we're needing additional info. So this is where we're gonna get the data that goes. Sorry, if I run it again, and type in EH1 1EJ. That's just a different postcode there. You can see we're in Edinburgh now, and the distance has changed, and it's the same sort of thing, but you can see here that we've got different data. So this additional info is what we're making here in this additional info function. So we make the label for it. That's great. That's great. Again, a lot. So this is dynamically creating the labels for it. Very good, very cool. And then these text variables are going to store the SHA, which is the Strategic Health Authority, the Parliamentary Constituency, which is the PC, and the AE is the Administrative Electoral Area. So that's those variables. Again, good to always have good variable names, self-explanatory variable names. And then all we really do here is just set the text variables to the corresponding value in the 2D in the 2D dictionary, or the 2-key dictionary. You know what I mean? So yeah, that's really quite simple. And then what happens now? Essentially, that's the end of that's the end of the program. Because that's the end of all the computing, because it's carried out its function. So there you go. That's how I did this. So yes, the code will be up on GitHub, so you can follow it using that. But thank you very much for watching. Goodbye.